Right, in this video, we're still talking about systems, but now we are dealing with word problems. So if we think back to when we originally did word problems, we would have something we would need to set up, define our variables, solve for that variable, and then that's really it. Same thing here. We need to read this, set up our equations now, because it's a system, it's more than one. And we need to define our variables because there will now be more than one. And we will either need to solve for one or solve for both, depending on what the question asks. Now, in these examples, most of them is just solving for one. Some of them we may need to solve for both to find the other, but we will get into that. And then the way you solve this is the same as what we did before. Substitution or graphing, and of course there's elimination, but we're not doing that. So what I'm going to do is I'm going to alternate between substitution and graphing for these word problems. So for the first one, of course, the most important thing is to read it and find what's important. So at the movie theater, the Clayton family bought 4 fountain drinks and 3 bags of popcorn. I'm sorry, I'm pausing while I'm reading because I'm noticing important things as I'm reading and want to kind of get ahead of that. And paid $22.50. The Hanks family bought 5 fountain drinks. Oh, wrong color. I'm trying to color code it so that I know what's what. And 2 bags of popcorn. And paid $23.75. We need to figure out how much is a fountain drink. Right? So with all of the information we were given, we need an equation for the Clayton family and an equation for the Hanks family, and we need variables. So first, the things we don't know, because they told us how many of each they bought, but they didn't tell us how much a fountain drink costs or how much a bag of popcorn costs. So I'm going to say that F is the cost of the fountain drink. And B is the cost of the bag of popcorn. Okay, so now that we have those two things, you will always need 2 variables here. Then we can write our equation. So 4 fountain drinks and 3 bags of popcorn. So if I took these numbers and I multiplied them by the variables, it would give me the total. So 4F plus 3B equals 2250. And I know that I was going back and forth. I have the sheet in front of me, just in case. And then the other one was 5F plus, 5F and 2B equals 2375. Now, if I'm going to solve this by graphing, then if you're using Desmos, you cannot have other variables. You have to use X and Y. So if you're going to use X and Y, what I would suggest is that you label them as I just did. Whatever the first one is, put X. Whatever the second one is, put Y. And with Desmos, you don't need to solve the equations to graph them. You can just put them in as is. So I could put in 4x plus 3y equals 2250. And 5x plus 2y equals 2375. And see what that is as an ordered pair. Alright, so 4x plus 3y equals 2250. It's going to graph that line for me. And then 5x plus 2y equals 2375. And I can see that point is where they intersect. 375 to 25. Was it 25 or just 5? Just 5. Oh. Right? I have to remember that this is x, this is y. X is the same thing as f. Y is the same thing as b. And it asks us to find how much a fountain drink is. So f is x. So I can say that the cost of my fountain drink is $3.75. Now, because of the way this is set up, we kind of know it's going to be one of two things, 375 or 250, which both of those were in our order pair. If we didn't remember what our labels were, we may be going the wrong way. We may have went the wrong way. Also, on top of that, once we set up our equations, because we were given those two choices, we could put 375 into F, solve that for B, and see does that work, as well as the 250. Now, I did not solve these equations for Y. However, on the test, if you get big questions, I say that like big, or questions with big numbers or decimals or things like that, you may just be able to graph it in Desmos and show just the setup work. So what I did here, name the variables, put the equation, put the order pair, and then tell me which is which. However, if they are more simpler numbers, you may need to graph that, which means you would need to solve both of these equations for y if necessary. So just keep that in mind. Right? From that one, we are now going down here. So Ryan works at a donut shop where he makes $10.25 per hour. And then he also works part-time at the school bookstore where he makes $8.75 per hour. He worked a total of 20 hours last week and made $196, basically total. And we're trying to figure out how many hours did he work at the bookstore. So there is a lot going on. So let's do this piece by piece. First, the things we don't know. We don't know how many hours he worked at both. So those are going to be our variables. Let's say D for donut shop for the number of hours at the donut shop, and B for the number of hours at the bookstore. I'm not writing complete sentences. And then B can be the number of hours worked at the bookstore. So now we know that. Those are the two things that we don't know. And then looking back, we know these two amounts is what he gets paid per hour. So these two amounts are going to be multiplied to the variables. So I can say 10.25D and 8.75B. Then these last two are both totals. One is the total number of hours and one is the total number of money. Well, if I knew how many hours he worked, I'd both multiplied it by how much he gets per hour and added those together, I would get the total amount of money he made. But to get the total number of hours he worked, I would need to know the number of hours he worked at the donut shop and the number of hours he worked at the bookstore and add those together. So these are going to be my two equations. 10.25D plus 8.75B equals 196, and D plus B equals 20. I'm going to fix this so it looks a little bit nicer. I don't know if that was better. Alright. This one I'm going to solve by substitution. Here, we were asked to find how many hours he worked at the bookstore. So when you have word problems like this, it's best if you solve for the opposite thing that they ask for. That way you end up with what they're looking for. What I mean by that is, if they're looking for how many hours he worked at the bookstore, if we solve for the number of hours he worked at the donut shop by saying this is D equals 20 minus B, or negative B plus 20. When I substitute this equation into the other, D is going to disappear, leaving just B, which is what I want. So I can put this equation into D. This is not liking me today. And solve from there. So this would be 205 minus 10.25B plus 8.75B equals 196. I could combine my B's to get negative 1.5 and then get rid of my 205. Yeah. And my last step would be to divide. Now, I do have some of this worked out already, which is why I knew some of these things. But for those of you that don't, you would just need to do this in Desmos or calculate those answers. And I'm going to go back and fix a couple things. This is the number of hours, so we need to specify. And then in this first one, this was the amount of money. So really all of these are just about practice. Recognize what you need to do, recognize what you need to solve for, define your variables, put your equations together, and either solve or graph. For our next example, at the gym, Kara, I'm not exactly sure, burns 12 calories per minute on the elliptical, and then 10 calories per minute on the treadmill. If she worked out for 1 hour and burned 676 calories, how many minutes did she spend on the elliptical? Right, so this is kind of similar to the last one we did because they give us a number, then they give us two totals. The total time she worked and the total amount of calories. So the numbers here are numbers of calories. So the two things we don't know are how many minutes she spent on the elliptical and how many minutes she spent on the treadmill. Right, so we can name those, and you don't have to name them whatever it's called. You could just name them X and Y if that's what you want. Sure, I'm pretty sure I said don't use T, but I'm going to use T in this case. So this will be minutes spent on elliptical. I think that's how you spell that. And minutes spent on treadmill. Right? We know that she burned 12 calories on the elliptical. We know she burned 10 calories on the treadmill. And if we were to multiply those two numbers by the time spent, we would get the total number of calories she spent. So the number of calories, 12, times the number of minutes, plus the number of calories on the treadmill, 10, times the number of minutes equals the number of calories, the total number of calories she burned altogether. They also told us that she worked out for an hour, where she spent an hour on both. An hour, because we're talking about minutes in these, is 60 minutes. And since I don't know how many minutes were spent on the elliptical or on the treadmill, those are just my variables added together. In this example, again, I'm going to graph, but in this case, I'm going to show you how I would solve both of these. For Y, to graph both of them if 676 or 60 were smaller. So I would solve both of these. So for the first one, that would be 10y equals negative 12x plus 676, and then divide everything by 10. Would be negative 6/5 x plus something as a decimal. And then the other one would be y equals negative x plus 60. And I could graph, both of those. What's going to happen when you graph this, because we have such big numbers, is that you're going to have to zoom out to find where they actually intersect. So just so you see this big, I'm going to start zooming out, and now I see my two graphs, and I just click as to where that point is, where they intersect, and that's at 38.22. And we were asked to find the number of minutes spent on the elliptical, E, which was x, so 38 minutes. And again, you could have also graphed these just using the equations that were given as well. For this one, we don't really need to solve this because we know the answer is going to be 27 because there's nowhere else to go. But I am going to set this up for you so that you see what that looks like. Angela has a collection of nickels and quarters worth $8.80. So that's your total. Her telling you, or this telling you that it's nickels and quarters are important. It also telling you that she has 68 coins total of nickels and quarters. And then it's asking how many quarters does she have altogether. So the number of both is what we don't know, because what we do know is how much a nickel is worth and how much a quarter is worth. So I can say Q is the number of quarters and N is the number of nickels. And we know two things. That one of these, her total was $8.80, and the other one, her total was 68. 68 is the total number of coins she has total, so that's the number of quarters and the number of nickels. $8.80 is the number of quarters and nickels she has multiplied by their worth. So a quarter is worth 25 cents, and a nickel is worth 5 cents. So that's how we would set that up, but we already know that the answer to this is 27. So I'm not going to solve this one. And I'm going to move on to the next. So now, the marching band is selling poinsettias and wreaths to raise money for new uniforms. Trey sold 7 poinsettias and 3 wreaths. So anytime it has like 2 different people, it's going to have this person has 2 things and this person has 2 things. Like the first example. And he raised she, $201. And then Molly sold 4 poinsettias and 6 wreaths and raised $252. We're trying to figure out how much is a poinsettia. So in this case, we have the number of each. We don't know how much is each. So that's what we're trying to find. After a while, it kind of gets repetitive because you're doing the same thing over and over again. Just the word problems become different. Okay, so we don't know the cost of each. So I'm going to say this is P and W, the cost of both. And then we were told that Trey sold 7 poinsettias and 3 wreaths and raised $201. So that's going to be one equation. And Molly sold 4 poinsettias and 6 wreaths and raised $252. Right? Now, this is a dilemma like in the last video or in the last lesson when we were talking about substitution. This is going to be one of those issues, and I just realized that this was supposed to be a plus. Where we're going to end up with a nasty looking fraction. This might be a case where I would just graph it instead, but I'm going to show you how I would solve this. It does not matter which one you choose because they both have a coefficient. So I'm going to say I want to solve for this W. So if I'm solving for this W, I need to get rid of this P. And solve. And simplify. So 4 over 6 is 2/3 P. And 252 divided by 6 is 42. Now that I have W by itself, I can go back to my other equation and put that in. What's nice about this is that when I multiply this 3 and this negative 2/3, this negative 2/3, the 3's are going to cancel or become 1, just leaving negative 2P. I don't know why I keep doing that. So now I can just solve this. I'm sorry, I didn't multiply. This is 126. So this would be negative 5P plus 126 equals 201. I can subtract 126. And when I do that, I get 75. So P equals 15. I can remember how to spell this. I didn't say this, and let me just do that. It was asking for how much is a poinsettia. So instead of choosing P to solve for, I chose one of the W's to solve for. That way I would end up with a P. And you could do it the other way too. Start solving and solve for P instead of W right here. But then you'll have to go back and put P into W, or put W back into P and figure out what P is. So this was, by process of elimination, it couldn't have been 22 because we're looking for a price and that one doesn't have a price. We also already went there, so we can't go back. Right? With this one, because it's talking about length of a rectangle and width, your variables by default are just L and W. So here, the length of a rectangle is 1 inch less than 3 times its width. Then, something else that's really important, they tell us that we're dealing with perimeter. Oops. And that the perimeter of this is 54. So with this, we have to go back and remember, how do we find perimeter? Right, so remember that perimeter is 2 times the length plus 2 times the width. We don't need to define our variables here because they are length and width. We do, however, need to put this into, further down, this into an equation, 1 inch less than 3 times its width. It's talking about the length here. 1 less than 3 times the width. So remember that less than is a turnaround phrase. So that means that 1 is going to end up at the back. And 3 times its width is going to be 3W. Now we can put this into our equation. We also know that our total perimeter was 54. So we're going to take this equation and put it in for L. So when we talked about this before, we kind of were doing systems without really doing systems. Right here, I can keep combining my like terms. Solve. So W equals 7 inches. However, that is not what they asked us to find. They asked us to find the length, not the width. So because of that, we are going to put 7 back into L. I'm sorry, that's W. And figure out what that is. So our L here equals 20 inches. Okay, for this one, Ariana's English test has 2 types of questions. Multiple choice questions are worth 2 points. Short response questions are worth 3 points. And then we know that there are 43 questions total, and the test is worth 100 points. We're trying to figure out how many short response questions are there. So the things we don't know are how many multiple choice questions there are, how many short response questions there are. So those are going to be my variables. And I just realized that I solved 2 in a row. So I'm going to graph the next, I'm going to graph this one, and I'll graph another one. Or I might just graph the rest. Right, so anyway, S is the number of short response questions. M is the number of multiple choice questions. Okay. From the problem, we know that multiple choice are worth 2 points, short response are worth 3 points, and the total test is worth 100 points. So I can put 2m plus 3s equals 100. I also know there are 43 questions total. And if I knew the number of multiple choice and the number of short answer or short response, I would get 43. So I'm going to go ahead and graph this one. Say that my m is x, my s is y, and put these directly into Desmos. So 2x plus 3y equals 100, and x plus y equals 43. When I look at these two lines, this is the point where they intersect at 29:14. We were looking for the number of short response, which was y. So this is 14. Okay. On to the next one. Okay. By elimination, I can't go backwards. If I went up to this basketball team, I wouldn't be able to go anywhere. So that one's out. This one's out. So I have 3 choices. We could either be done or have 1 more or have 2 more. We'll see. So for this one, Ben and Landon took turns driving on their recent 820 mile trip. So that's a total. They're telling us how many miles total. Then they say Ben averaged 60 miles an hour, while Landon averaged 56 miles an hour per hour. It then also tells us the trip took them 14 hours, and we're trying to figure out how many of those 14 did Landon drive. So what we don't know is how many hours they both drove. So that's what we're going to define our variables as. I'm going to make these capitalized because they're names. So this will be the number of hours Ben drove, and this is the number of hours Landon drove. Okay, and then they told us their averages and the total. So Landon averaged 56, Ben averaged 60. And we know it took them 14 hours and they were on the road for 820 miles. So for the 820 miles, that's per hour plus the average, or times the average. And then the 14 is just the number of hours they drove total. Right? Because this video is getting a little lengthy, for sake of time, I'm going to graph this one as well. So 60, oops. X, I don't know why that keeps popping up, plus 56y equals 820, and then x plus y equals 14. So for a second, it almost looked like they weren't going to intersect and they were parallel, but if we look down further, I can see that they're going to intersect. Looks like at that point, 9.5. We were looking for the number of hours Landon drove, and that was y. So I can say that he drove 5 hours. Right? I'm actually going to leave this there and stop there. The notes are posted so that you can do these last two, but these are going to be very similar to ones we've already done. We will have more practice on this.